My name is Bryan Blair. I'm an instrument scientist and I'm the principal investigator for the LVIS sensor. What's really interesting about being an instrument scientist is it's not really a precisely defined field. So essentially you're trying to translate scientific requirements into engineering requirements. So it's a pretty broad field. There's a lot of room for creativity. It's very exciting. So LVIS is a high altitude airborne laser mapping sensor. The acronym stands for the Land, Vegetation, and Ice Sensor. It's designed to operate at high altitude so we can map a much larger area very quickly. Because it can map such a large area, we can look at landscape scale processes. So we may not look at an individual patch of vegetation or a small feature of a glacier. We would map the entire glacier system. So in 2009, we flew to the Antarctic Peninsula, and as we were mapping it with LVIS, we were taking high-resolution camera imagery at the same time. So we took all those images, mosaicked them together, and merged them with the LVIS data. Now we have a product that you can actually interact with and see all the different views. You can go walk around places that you could never physically walk around because they're too dangerous. So when we developed that, it was with the intention of giving scientists the ability to interact with the topography data in a way that they never could, just looking at it flatly on a computer screen. Maybe they'd pick out a different way to approach a problem, or it would inspire them to do something different with the data. So where we're getting to now, we flew the LVIS sensor that was developed for this high altitude drone, the Global Hawk. That can fly at 60,000 feet for up to 30 hours. So we used to fly for 3 hours on some aircraft. Now the Global Hawk is 30 hours. We used to have a few 100-meter swath. Now we have a 4-kilometer wide swath. But the other advantage of flying high is that you burn less fuel, you can fly faster, and you can fly a much larger area. Most scientists believe that you can only get small amount of area mapped. As you bring in LVIS, and especially Global Hawk LVIS, all of a sudden you bust through that limitation. You're mapping huge amounts of areas. And what could have taken 10 or 20 years with some of the older sensors now could literally be done in a single season. You could almost map the entire Greenland ice sheet in a single season. So everything that we do with LVIS, whether it's science application development or algorithms or technology prototyping, leads us to planetary mapping. We want to map the Earth because we want to map everything and we want to do it often. But we could also apply this technology to other planets as well.